This is John. He's really good at what he does. This is Ben. He wants to learn what John does. But John's busy with an audit. What if we could record and analyze what John does? And so, we created AuditMon, a tool to do just that. AuditMon is built on top of another great tool, Atlas. Atlas is an Eclipse plugin that amplifies human intelligence using static analysis. Given source code, Atlas indexes and extracts relationships from the code to produce an interactive graph. AuditMon passively observes an analyst by recording nodes that are selected through mouse clicks in the graph. And because Atlas maintains a two-way correspondence with the source code, AuditMon can directly observe what an analyst selects in the source code itself. The order that an analyst audits code is just as important as when and what an analyst audits. AuditMon records this information by adding new nodes and edges to the Atlas graph during the audit. Let's take a look at a toy example. Consider two nodes, N1 and N2, in the Atlas graph which represent some code artifacts. John starts his audit at time T1 and then selects node N1 at time T2 by clicking on the code artifact in the source code. A new observation node is created with timestamp T2 and a directed edge is added from the start node. For convenience, we number the edges relative to each audit session. In order to denote that node N1 belongs to the inserted observation node, we add a membership edge from the code artifact to the new observation node. Next, John selects both nodes N1 and N2, so AuditMon inserts a second observation node with member edges from each node. At time T4, John decides to stop the audit and go to the bathroom. Later at time T6, John resumes his audit and selects nodes N1 and then N1 and N2 again. Since observation nodes and edges already exist for these selections, we simply update the graph. After John is done auditing, Tom, who is another great analyst, decides to inspect a few things for himself. Tom selects nodes N1, then N1 and N2, before going back to node N1 and stopping his audit. Since Atlas provides a convenient graph traversal interface, recovering any portion of either John or Tom's audit is trivial. Let's take a look at AuditMon in action. First, we create a new audit session for Ben. We start the session and click methods A, B, and C, and then A again in the test project. For this demonstration, we use an Atlas Smart View to view and inspect generated observation graphs in real time. We can see that AuditMon is recording timestamps for each node, relative edge numbers, as well as click origins and stop reasons. Saving an audit is simple. Later, another analyst can pick up where the first analyst left off by loading the saved index. Here, John creates a new session and clicks on methods B and then A before stopping his audit. Notice that AuditMon is reusing existing edges from Ben's session in the observation graph. With this technique, one index can store multiple audit sessions. You might be wondering what we can do with all the information collected by AuditMon. Well, for starters, it's now simple to reproduce the degree of interest model proposed by Krishnan and Murphy. First, let's restore Ben's previous audit session. Using the observations graph, we can recreate and update the degree of interest model in real time for any session in the index. And because the model can be created retroactively, we've added a concept of granularity to the model. For example, a click on a data field or a method can be attributed to its parent class, source file, package, or even its project for multiple project applications, as well as other relationships. Another application might be to monitor a typical peer review that contains multiple reviewers. From the observations graph, we have enough information to then visualize the human code coverage. Going back to our test application, we export line-by-line time metrics for both reviewers, John and Ben. Darker colors indicate more time was spent on the line relative to the current source file. When we visualize both together, we notice that nobody has audited methods D, E, F, and G, and that perhaps the peer review is incomplete. The application we are most interested in, however, is the ability to compare audits from different malware analysts. Here is some real data we collected from two analysts during an audit of an application called Android Bible, which contains malicious code that enables remote code execution by the attacker. The analyst on the left did not find the malware and looked in more packages than the analyst that did find the malware. Looking at the number of repeated observations per minute shows us what the analyst was interested in during the audit. In this app, both of the analysts spend a lot of their time auditing connections to the internet. We think that AuditMon is a simple idea that will enable interesting new types of analysis, but don't take our word for it, try it yourself.